Hi, I'm Sarah Gutterman. I'm the CEO of Green Builder Media, and I am here today with Christoph Lohr, the Vice President of Technical Services and Research for IAPMO. You've often talked about the hidden cost of water inside of homes. Why is water system design such an overlooked lever in the housing affordability conversation, and why should builders care about it right now?
So what I first say is that really plumbing tends to be a bit overlooked. I think in large part due to its own success. Oftentimes we only think of plumbing when something's not working, and more often than not, the plumbing systems are working. But in this case, because of some of that oversight of plumbing and its success, we haven't really updated some of our ways of doing design. And so, you have at this point kind of a hidden cost center, and we're utilizing a very old method back from the 1940s, predominantly the Hunter's curve fixed unit method, to size our piping system. So you have these hidden costs of connection fees and pipe sizing that's oversized. And really what we want to drive towards is modern sizing, and that equals direct savings. And that's the water demand calculator, which was included in as early in the 2018 UPC and the 2017 Water Efficiency and Sanitation Standard, two of the standards we created, allows for this right sizing of piping, really reduction. And really there's this permitting risk that comes with oversizing. Water scarcity is already kind of creating a lot of entitlements and challenges between jurisdictions and water purveyors. A lot of cities are beginning to require net zero water plans or pausing new hookups where water supply is constrained, including my home state here in Arizona. So we've overlooked it for so long, but now is really the time to look at this new way of right sizing at the front end of design and construction.
We often talk about energy efficiency and electrification as critical pathways to zero, but water efficiency rarely gets equal airtime. How do you see water efficiency fitting into the larger decarbonization and affordability narrative for housing?
First off, we would definitely want to look at the WaterSense program, which since 2006 has saved almost 8.7 trillion gallons of water nationally. So proof that water efficiency is a high impact, low cost path alongside energy retrofits. But right-sized water systems now are providing additional savings with that and working very well along with these more efficient plumbing fixtures, in part by shortening that time to tap and reducing hot water volume sitting in the pipe, something in the technical realm we call structural water waste. And all of that combined works on lowering bills and emissions and the time waiting for hot water to come to your shower, and all that's tied to water heating.
The IAPMO water demand calculator has been a game changer. Can you walk us through how it works and why using it results in smaller diameter pipes and lower material and labor costs for builders?
So when it comes to sizing a pipe on the engineering side, the design side, there's two main criteria that we use to size the pipe. It's your available pressure and then your peak flow rate, which is an estimate of what the highest flow rate would be based on what that probability of simultaneous uses of all the plumbing fixtures, the showers, the toilets, the sinks, everything else in your home. So that peak water demand, which is embedded in the Uniform Plumbing Code, UPC, and we stand, it estimates what that whole building and then the different branches, if you imagine a tree, your trunk, and then your branches out to the tree before you get to your twigs, what that likelihood of simultaneous use is. And so the higher that estimate is, the bigger the pipe we need to have to accommodate for that. So when you get a more accurate estimation of that peak flow rate, and the Hunter's curve, especially on like some larger multifamily, overestimated that peak flow rate by a factor of 20 times, not 20%, but 20 times. Whereas the water demand calculator typically is in that range of 2 times oversized. So there's safety factor, but not as gross of a safety factor. That allows you to get a smaller diameter of piping, on your mains and your branches. And so, especially with those lower diversified modern fixtures and the not treating a home like a sports stadium, all of that allows for smaller service line, mains, branches, risers, et cetera. This cuts down on material fittings, the transportation costs, and often shrinks the meter size too, making it more accurate and reducing some of the inaccuracies of oversized meters. So all of this, is these positive results that come from it. And one of the reports that we commissioned with Stantec, documented many of these effects across single.
How significant are the cost savings when builders right-size piping using the water demand calculator compared to traditional sizing methods? Can you give us some real-world examples or a range?
We looked at, the Stantec report in terms of construction cost savings, looked at a 45 unit building, and the overall estimates based on the construction costs and the connection fee savings. There was a range, again, depending on where you're at, there's different costs to connection fees and pipe materials based on what region of the country, but a 45 unit building could see somewhere in the range of $86,000 to $190,000 in savings. When we looked at other documents and other studies out there, a typical single family home could be $2,000 to $5,000 per home for the pipe materials and construction cost savings. We just found out about a project in Portland, Oregon, low income housing. And that particular project that we did a webinar on, and done some training on, that one saved almost $400,000 for that particular complex. I think it was about 50 homes, if I remember correctly. So we're seeing some pretty amazing savings. It just depends on where you're at. If your connection fees are lower than some of those, and your pipe materials are lower cost, then it might be a little bit on the lower end, but again, we're seeing a pretty high range, oftentimes, especially for multifamily, 6 figures. For single family homes, $2,000 to $5,000. It doesn't solve the housing affordability, but it's certainly a step in the right direction.
Beyond upfront cost savings, what long-term operational benefits do right-sized systems offer for homeowners, especially around hot water delivery, water waste, and energy used for water heating?
The two, I guess, there's kind of two sides of this amazing coin. One is, there's just a sustainability benefit, which also, can improve operational costs. So the first one is faster hot water delivery time. Because smaller piping, you need less flushing time to displace the water that's going to your shower. A lot of people don't, when they turn on the shower, they wait for that water to heat up because the water's cooled off over time. And there's a certain amount of structural water waste or less water wasted that occurs by that. And additionally, less energy that's needed to heat that water. And so, when you look at the studies for water waste, it equates to about 500 gallons per home per year, which is about the same as an outdoor hot tub. The other benefit is improved water quality. When you lower that or you reduce the pipe size, you right size it, get it more in line with the actual flow rates, you're limiting water age and stagnation. And there's a lot of important public health and safety benefits of that right sizing and lowered water age when it comes to single family, but also multi.
Now, for builders tackling new construction, what are the top 3 most impactful water smart design decisions they should be integrating in from day one?
I would say, first off, what we've been talking about, Sarah, adopting the water demand calculator and using that, whether it's from the UPC or the We Stand. Start early on in schematic design. Your forward design planner should definitely be looking at this for your developments or for your apartment complex as well. The second would be specifying water sense labeled fixtures and appliances. That works really well in tandem. There's not going to be there's going to be an ongoing cost savings with both of those to the owner. And then last but not least, and it's worth mentioning here, is designing for distribution efficiency. So one of the things that we kind of mentioned about in the engineering realm is centralizing wet walls, using shorter hot water runs, bring the water heater closer to the fixtures that you serve, not having such a spread. And these are things that are located in IAPMO's water efficiency standard, the We Stand, as I mentioned before. And so these kind of things, all 3 of these in tandem, can really help communities and builders implement water savings that are also cost effective.
For retrofit or remodeling projects, Christoph, what practical water efficiency upgrades should remodelers and homeowners prioritize in order to improve performance without driving up costs?
One is, swapping legacy fixtures for water sense models. The next one, as mentioned, any repiping, utilize that water demand calculator. Actually, one of the best ways in using the water demand calculator is for adaptive reuse or renovation projects, because you might be able to show, instead of having to upsize your incoming water main, you might be able to use the existing one that's in place that was sized with that older methodology. Last but not least, take a look at smart leak detection and whole home monitoring, especially in older buildings. If you're reusing piping, there's that potential that piping over time becomes a bit leaky. So having that included into it, maybe even as early as some of the construction, you might be able to determine if there's an ongoing leak that you need to repair during the construction process. So those are just 3 quick and easy ways that have long-term value for the builder and then also for the homeowner.
Water reuse systems like gray water and rainwater harvesting can sound expensive or complicated to integrate. What are some scalable, cost-conscious ways that builders can start introducing reuse systems, especially in drought-prone areas?
The first thing always to do is to check with your local, wherever your jurisdiction is. Everybody has different rules on what sort of on-site water reuse methods and technologies you can use. But in general, there's a lot of opportunities and to find the right technology to go along with what you're trying to do in the area that you're working in. So you really want to fit for purpose in that way. And rainwater and gray water for irrigation and toilet flushing are some of the lowest complexity entries when it comes to that. IAPMO, we have a number of reuse standards. We stand covers a lot, but we reference other standards such as NSF 30, which is targeted primarily at residential. If you're doing like a multifamily building, IAPMO Z1324 is a good one to look at. ARCSA has a number of guidance on rainwater catchment systems. So it's really important to have these kind of industry standards, because our industry, the plumbing industry, we rely on standards like this to make sure that we all meet a common practice, basically. As jurisdictions increasingly discuss net zero water planning and broader use, builders who want to pilot basic standards aligned reuse are really being positioned well, because they're kind of leading in a way, and they're actually able to sort of shape the conversation too. So from a long-term strategic standpoint for builders, getting involved in this early, especially as some jurisdictions are looking at making requirements around water reuse, really will set up that organization well for long term, because they're going to have some of the most initial experience in that regard. So it is something that we're seeing a trend in industry right now.
What policy or regulatory shifts could most accelerate the adoption of water efficient and right-sized plumbing systems across the U.S.?
So first off, it's interesting. We've had 18 jurisdictions that we know of, 12 states, 6 cities that have adopted the water demand calculator. But what's interesting is there's a number of them that have actually codified right sizing in the sense of mandating it. Places like Castle Rock, Colorado, Seattle, King County, Vancouver, all these places are now starting up. And that's Vancouver, British Columbia, and Canada. These have all started kind of making the Uniform Plumbing Code Appendix M a requirement as part of submitting permits. There's other opportunities too, because some of the utility sides are also aligning towards this as well, particularly because of the concerns of oversized meters and the potential of losing revenue and not seeing leakages. So you're having a number of places that are starting to recommend right sizing the water demand calculator and really decoupling the connection fees from that legacy meter sizing based on the old school, almost 90-year-old method. And it's worth noting AWWA M22, Manual 22 on, from that focuses a lot on the utility side. They actually recommend the use of the water demand calculator. One of the other policy regulatory shifts is definitely the incentivization of water sense homes and reuse. We're seeing rebates, tap fee credits for efficiency, and reuse installations accelerating in the market. And so there's definitely a shift in a lot of places that are looking for opportunities for some kind of water savings, especially as some of our traditional water sources are starting to dry up. Places like Arizona, we've seen a lot of cuts around the Colorado River. So these topics of what can we do on a decentralized, local, on-site level, the conversations continue to amplify in not only volume, but also in frequency.
What innovations or technologies are on the horizon that could further disrupt the water efficiency space, especially in ways that support affordability?
So I think that, my sense is, if I was going to make a prediction, I think that no matter what happens, there are going to be people that are going to want to see that type of efficiency in their homes. I just bought a new home. I'm actually calling from my office. We worked with KB Homes and they use water sense fixtures, and that was one of the things that actually I looked for. So I'm not the only one. I think there's a lot of people out there that just want to see it in some way, shape, or form, because people are mindful. And so my sense is that there's going to be some form and some segment of the population that are going to want to see those types of things in the homes that they buy.